Hi, Kalas. I hope you had a great 4-day weekend. I know I did. I spent a lot of time with my kids and my family and my wife. And I wanted to do a quick follow-up on section 6.4 since I taught it and I graded the worksheet, so I wanted you to have some feedback. And then another reason why I made this video is because I'm actually not in period one. And because I taught the class, I wanted to give you a review and some feedback on your work. Um, Section 6.4 dealt with amplitude, period, and vertical shift. If you recall, we did a Desmos activity where you got, to move, a few dots that shifted your sine function up or down. You made it wider, or you made it taller or shorter, right? Wider or shorter too. And I just wanted to do a quick review. But first, we're going to review your assignment, and I'm going to give you overall feedback on what I saw in most of your papers or your worksheets. So number one, there was a few minor errors. In a lot of your responses, I wrote, I need an equation, not an expression. So what that was meaning is that an example of that is that 2x plus 3 is an expression, right? And f of x equals 2x plus 3 is an equation. I will not be able to graph this because it's not giving me a command of what to do. In this right here, f of x, I know by intuition that x can mean any number, and I can plug that number in and it will give me an output. It will give me another number, and that would mean go into my coordinate planes x and y. So that's what I was meaning. So if you can fix that, I will, up your grade real quick with those problems. Now, problem number one, we wanted you to use all 13 points from section 6.2, in addition to the max and the minimums at 5, 15, 25, and 35 seconds. Otherwise, the graph kind of looks like it goes flat and goes down, right? And there are minimums and maximums on the graph. Question number 6. This is probably where most people struggle. I need an answer that describes the how. For example, the question was, how would your graph change if the radius of the wheel was larger or smaller? So this is when we start comparing our Ferris wheel to our sine function, right? Our sine function that goes like this. So as a sentence starter, I wrote this. This is something that I would have liked to see, and I would still like to see. You can modify it, change it, use the same if you need to. When the radius of the wheel was larger, the graph, and tell me what it did. When it was smaller, the graph, tell me what it did. And I need to know what happened on each occasion. I believe the problem asks you for the height of the center of the Ferris wheel, and when the wheel rotates faster or slower, right? You have to tell me how your graph is being affected when it's going faster or slower, when it's larger or smaller. So that's what I was looking for. Question number 7 is being very explicit about the equation. So in question number 2, you have the equation f of t equals 30 plus 25 sine of 18t. So tell me what happened in each of the portion of the equation and recognize what part of the Ferris wheel each represent. So what does the 30 represent? When it's smaller or larger? What does the 25 represent? And what does the 18? And what is the 18? And what happens, right? What happens when it's larger? Let's say number 18. Let's say what happens when it's 20. What happens when it's 15, right? So refer back to the equation. That is what I was looking for in answer for question number 7. If you just told me, well, it's smaller and larger, well, tell me what is smaller and larger. Again, remember those 3 words, amplitude, period, and vertical shift, right? And we're going to go over them real quick before you you have your papers back. Finally, in question number 8, show me how you found your numbers. A lot of you had 24 for your rotation, right, for your angle, but I didn't really see any work, and I was just being a little bit picky there. Also, in question number 8b, is also telling you that the graph, right, or the Ferris wheel, is doing a revolution clockwise. So when we studied the Ferris wheel first, it was going counterclockwise. Now I want to know what it does when it does it clockwise, right? And we're gonna go over those things in a little bit. So number 1, from our review from doing the Desmos activity, there was the vertical shift up and down of the entire graph. There was your period, right? The cycle that when it starts repeating again, right? It's wider, it's shorter. And then with the amplitude, right? Your whole graph going like this, boom, boom. And we're going to review that Desmos activity real quick. It's loading. So, if you look right here in my Desmos activity, right? The vertical shift, the definition is the number of units that the sine graph has been shifted in the vertical direction from line y equals 0. Where's my line y equals 0? If x equals 5, y equals 0. If x equals 10, y equals 0. If x equals 1,000,000, y equals 0. Right? This is my line, y equals 0. Therefore, my vertical shift is affected by the orange circle right here. This one. But notice what happens to the graph, right? If my starting point is at 5, and then I move that to -1, the entire graph, so notice that the entire graph goes down with the vertical shift. It's not just the y-intercept, right? All the points on that graph get shifted however many units down, however many units up, right? It's the entire graph. See that? So cool. Period, right? The shortest repeating portion of the sine graph is called a period. So recall back when we did, when you were doing the intervals, right? When does it start repeating again, right? So you see, this is my starting point. My graph is going, everything looks different. Everything looks different as of now, right? This may be the same as this. But look, it's still going at a different, I don't see any line over here, right? There it goes, and it looks like starts up again, right? It looks like it will do exactly the same thing here. So that is my period, right? The length of each cycle. This is one cycle. So right now my cycle is at roughly around 4, right? And I can move it so my cycle is 5. I can move it so my cycle is 10, right? You see that? Period refers to your x values. And I can even go down to 1. Now look what's happening, right? If my period is smaller, look what's happening to my graph. It's kind of like shrinking like this, getting skinnier, right? So that is called the period, right? And then if I make it bigger, it becomes longer like this. Next definition is our amplitude. The height of the function from its resting point. We determine that the resting point is right here, or half the difference between the maximum right here and the minimum value down here, right? Half the distance. So if we go to half, it would be about here. So let's figure this thing out. Pretend, let's see, I'm gonna move this to 2 and pretend my amplitude, which is affected by this purple circle, is just about here. So starting point here, I go up 1, up 2. So my amplitude here is 2. You can also find it by going down 1, 2, and see I'm on my minimum right here. Or I can take the distance between here and all the way here. If I draw 2 imaginary lines right here, 1, 2, and if I find this distance on the y, and I divide it by 2, then that will give me my amplitude, right? So my amplitude affects, if you want to call it in any other terms, how tall or how short my graph is, correct? Perfect, you see that? You can actually have the amplitude go different ways. See, taller, shorter. So that was our vertical shift, our period, and our amplitude. Vertical shift, period, amplitude. Those are the 3 definition words we found. Finally, I wanted to leave you just with this Desmos activity I created that kind of represent what's happening to the height of the Ferris wheel and the graph, the relationship between the height and the graph. So remember, pretend this is just your circle of the Ferris wheel. This was the rider at the farthest right, the point farthest to your right. Let me see, which one would be your right? Maybe this way. Depends which angle you're looking at me. But this right here would be the position farthest to your right. Now, on this particular Ferris wheel, we're gonna go clockwise this way. Clockwise, and I'm gonna explain why I'm going clockwise. So, once we start going clockwise, see what's happening to this black dot? It's the same height as in my Ferris wheel. See that? Now it's at its minimum, and it's going up, and the green and black are now roughly around their maximum, more or less, right? I'm not perfect, but if you see here the height here, I believe it's about 5, maybe around a little bit less than 5, 4.7. See that? That's about their maximum. But see how they're moving in conjunction? See, now it's going down on my sine function. Clockwise, right? And I was telling you about clockwise earlier. So I'm going clockwise on my Ferris wheel, right? What does that do to my graph? Let's start again. If I'm going clockwise, see where my graph goes? See where my black dot goes? It starts going down, right? On my sine graph, going down. Let's go counterclockwise, right? I'm going to change just this real quick so it follows me. So let's go counterclockwise, right? Do you see what happened to my sine graph? It kind of made this flip, right? For example, look at this right now, okay? My height right now, my max right now is here, roughly around 1.5 or so, right? Roughly around there. If I change this to negative r sine of x, which by the way, r is my radius. Let's see how from my max became my minimum. It flipped, right? So, and let's see what does it do. What does it do to my height and my Ferris wheel? Now we're gonna go counterclockwise, right? Look, amazing. The heights are the same height, and it follows as I go a full cycle, and it's gonna start repeating itself, right? The height of my Ferris wheel is the same height as my sine graph. So that was what I needed to tell you. I hope you can turn in your assignments after you're done. I'm available during lunch in this room, 813. Thank you.